Good morning, students and teachers. Today I'll be presenting my TOK exhibition. Now, the prompt I've gone with is bias inevitable in the production of knowledge? To start with, we got to ask ourselves, what causes a bias? For this, we first need to understand the different types of biases. There are five in general, them being confirmation bias, selection bias, outliers, unconscious, and confounding. Although for this presentation we'll mainly be focusing on unconscious bias, as most of the time, during production of knowledge, we do not purposely try to be biased. Unconscious bias are social stereotypes of a group of people or individuals that form themselves outside of their conscious thoughts. Haven't got it yet? Well, how about I give you an example of myself? In school, when we learn math, I always have some sort of prejudice against it. I would already hate some topics only because I had read somewhere or my friends had told me that it's just too difficult, or because the questions seemed like they would take a lot of work. That prevents me from opening up my mind and understanding the topic. With there being something negative about the topic in the back of my head, I struggled to fully learn and gain the knowledge in that particular subject. Although later on I try my best to ignore the bias already in my mind, doing something with reluctance never fully allows one to actually do it. Now, to answer the question, is bias inevitable in the production of knowledge? The answer simply is just no. Bias can just never be eliminated no matter what. But we can do our best to avoid it. Even if we consciously attempt to be unbiased, our conscious mind will always have its preferences. Now coming on to the first object, which is quote unquote the big K. Here's an image of it. And you would think the idea of scientific measurements has absolutely no bias involved, and that scientists precisely carry out measurements. Well, in science, measurements are done against a standard, but standards themselves may change naturally, and when they do, our new measurements become biased in a certain sense. This illustrates that even specific measurements may be biased for reasons that we cannot control. Let me tell you about the kilogram and how it was defined and measured up until very recently. So taking a boulder and saying that a kilogram is a mass equivalent to the mass of such and such boulder is the only way for us to define a kilogram, right? That's what you think. And that actually is the case. This boulder actually exists and is known as the quote unquote the big K. In 1889, scientists gathered together and took an alloy of platinum and iridium and just decided that the mass of this object will be what we call 1 kilogram. It has been housed at the International Bureau of Weight and Measures in France ever since. Although the problem arises when even though there's been countless attempts to keep it intact as much as possible, an almost absolutely perfect vacuum housed under three bell jars which access to the previous cylinder requires three keys, of which only two are kept in France, the weight could still not be preserved, and it's actually been proven to have become lighter. It's lost approximately 50 micrograms of weight, which is the weight of an eyelash. Now I know what you're thinking. That might seem like such a minor amount, but what that basically means is our measurements of weight today is systematically biased in relation to what we agreed to consider 1 kilogram 130 years ago. And that just shows the bias is inevitable, as the big K will change its mass naturally, no matter what we try and do to prevent that from happening. Now, going on to the second object, it's a specific calculator module called the Casio FX83 GT Plus calculator. And here's an image of it. Well, you would never expect your calculator to give you a mathematically wrong answer, would you? You would think there is surely no bias involved in calculations and formulas. An object to represent mathematical reasoning would be a calculator, hence one of the reasons I went with this object. Now what if I told you that one thing you trust so much to give you the right numbers and do the right process when you tell it to can also be wrong and in conclusion, biased. Now here's the scenario. In this specific calculator module, when you put 11 to the power of 6 divided by 13, the response you get, now we're going to get quite numerical here, is 1.56 times 10 to the power of 8 divided by 3600, hear me out, times pi. Now, the thing with pi is it's an irrational number, which means by definition that it cannot be expressed as a fraction, leading to the answer you provided by the calculator being obviously incorrect. And that basically contradicts the nature of mathematics. This particular calculator gives a wrong response to this particular problem but not to any other. The reason being that pi is infinite, while the calculator's memory is not, as the power of our technology cannot be as infinite as mathematics. Therefore, the calculator uses an approximation. Interestingly, other similar examples do not work this way. It's only 11 to the power of 6 and only when divided by 13 in this specific calculator that produces this paradox, and we do not yet know why. Now how this links back to my prompt is that even in something as certain as mathematics, there could still be mistakes. It's not mathematics itself that's wrong here though, but the technology that we use to do mathematics. Moving on, it basically shows that mistakes in mathematical calculations may also be unavoidable, unless we create technology that is infinitely powerful, and as of now, we cannot recreate this infinite accuracy that is intrinsic in mathematics, basically leading to the conclusion that it's therefore inevitable that some mistakes will be made, and lead it to be systematically biased. Now conclusively, bias while producing knowledge is unavoidable, unless the extremely rare moment occurs when you're learning about something for the first time, just as a baby learns to walk. Thank you for your attention.